So sometimes it's hard to understand if a graph is sine or cosine. We're going to go ahead and start with problem 1. And by the way, quick reminder that if you need some textbook advice, I have also typed up the corresponding pages of the materials that we're discussing in this lecture video. Okay. So some of you wanted more explanation and more examples on graphing. That's what we're going to do today. Here is a graph. And we're going to go ahead and actually give two different equations for this. We're going to give one sine equation, and we're going to also give a cosine equation for it. So in other words, we can use either one to go ahead and give this graph an equation. We also want to go ahead and show you an example of a more difficult problem where we do end up creating the equation based on the graph. I know we did some of that sample work with period and amplitude. So if we go ahead and if we were to extend this graph right here, right, it would go ahead and hit this at 4 pi. Right here would be 3 pi right here. So based on that, we're going to go ahead and focus on the sine, right? We easily see a sine graph right here. So looking at this, we know that the amplitude would be 2. I totally messed that up. It should go not as low, but the amplitude would be 2. And this is a sine. The question is the period. So in a regular sine graph, we would expect it to be like this, right? And the period would be 2 pi. So we don't quite have that. To find the period, we would take the 4 pi minus the 0. Right? The final point minus the initial point. And that gives me 4 pi. But that's a period. We want the b value to go right here. So the b value we said was 2 pi over the period. In other words, 2 pi over 4 pi. The pi's cancel out. And the 2 and the 4 reduce to 1/2. So what we have is 2 sine 1/2 x. If you want to get fancy, put in parentheses. Okay. There is no vertical shift or horizontal shift because in this case it started at 0. And if it starts at 0, then we don't have a horizontal shift at all. Okay. And you'll notice that the max is at a 2 and the min is at a -2. So there was no vertical shift either. When you have a vertical shift, the max and the min are not the same number. Right? They're not the same distance from, like in this example. Okay, so one name for this graph would be fx equals 2 sine 1/2 x. And I'm going to leave that up there. Another way to look at this graph is a little bit more difficult. If we were to look at this graph as a cosine graph, right? So right here, and I'm going to extend this. And of course, this graph would go to this point right here. Keep going. From here to here would be the cosine. And it's not only a cosine, it's a negative cosine, right? It's inverted. Because we'd expect it to, if it were a regular cosine, it would look like this. All right. Now, what we're looking at is a f of x, a negative cosine. However, the amplitude is 2, right? The distance from the reference line to the max or the min is 2. This is going to be a -2 cosine. The period. Let's find the period. The period is going to be the final minus initial. So the final is right here. The initial point is right here. That's 3 pi minus pi minus a -pi. That ends up giving me 4 pi. So ironically, even though it's a cosine instead of a sine, the wavelength is still the same, right? Because if we're going from peak to peak or point to point, regardless if it's sine or cosine, it'll be the same period. And so B would be the period, 2 pi over the period. And that's going to be 2 pi over 4 pi. And that should look familiar, 1/2, right? But stop right there because this cosine did not start at 0. It started at -pi. So there's a shift, right? This whole thing shifted. Let me erase these. It shifted over. It should have been here, but it shifted over to this point right here, to negative pi. So we do know, this is the first point of this graph, right? Here's point 1, here's point 2, here's point 3, here's point 4, and here's point 5. So we know the first point is negative pi. So the horizontal shift is negative pi. But that's not going to go here because it's going to be bx plus c, right? So the question is, what is c going to be? Well, if you recall, the horizontal shift is negative c over b. I want the c by itself. So if I multiply both sides by negative b, I get c is equal to negative b times the horizontal shift. And we know what b is. B is 1/2. So what I'm proposing to you is c is negative 1/2 times the horizontal shift. The horizontal shift is negative pi. So that makes c would be pi over 2. That's pretty fancy stuff. You'll notice that I pretty much did the same thing twice, right? We did the period the same, we did the amplitude the same, and it's almost the same except that for the fact that this is inverted, right? The cosine is inverted. The other difference is that we have a pi over 2, right? We have a phase shift. We have a horizontal shift, which is signed in half. Okay. Now, this is only one possibility. There could be many other possible equations that we could derive from this. Okay. For example, we could have actually began a regular cosine from this point and could carry it all the way over to what, 5 pi. Okay. But I was using whatever graph we have available here. I would challenge you to create, if you're interested in your understanding, those of you that are interested in that, I would challenge you to make another cosine equation, but to do it starting from here with your initial point, and then with 5 pi as your final point, and see what happens. Problem 2, cosine. I guess we're going to graph this bad boy. So let's do it. A is 4. Do this right. Keep your signs. A is positive 4. B is positive 2. C is negative 3 pi over 2. And K is negative 1. So remember, as we're doing this, you should already be thinking about, okay, what's going to affect what, right? A is the amplitude. B is going to affect the period. You know, if the number is bigger, the period is going to be smaller. If the number is a fraction, then the period will be bigger. C is going to affect the shift. It's going to move it over. I know it's negative right now, the C. So it's going to go ahead and shift this over to the right because it's opposite. I know that K is going to be a vertical translation, meaning that it's going to drop everything by negative 1 at the end. And I know that we will always leave this at the end. That's your last step for when you're done with your graph. Okay? I did not mean to do that. Okay. We'll do the usual, right? Find the amplitude, the absolute value. Find the period, 2 pi over b. We will find the horizontal shift, negative c over b. This is a pretty big problem. So negative 3 pi over 2. I already goofed that up. You see that? Negative 3 pi over 2 divided by 2. So the negative is part of the formula, but then the actual c value had a negative itself. So this is going to end up being positive, right? This will not be, let's see, what do we have here? This will not cancel out. So those of you that are trying to squirm your way out of this, say, oh, it's going to cancel and be 3 pi. That's very wrong. Let's do the math, right? Let's do that's negative. It's going to be positive. Make up your mind over 3 pi over 2 divided by 2 over 1. That's 3 pi over 2 times 1 over 2. That's 3 pi over 4. Okay. So remember, like I said before, like if you needed that one skill to be successful in the class, what would it be? Well, that skill is going to be keep flip change. Okay. So we're looking at a horizontal shift of 3 pi over 4. Let me go ahead and clean up some room here. Recall that this shift will also be the first point. Okay. Now the increment. The increment would be the period over 4, right? You always take the period and divide it by 4. Notice that they are the same, okay, which is great. Okay, let me do this elsewhere. So we got 3 pi over 4 is my first point. I don't have to do any manipulation of the denominators or numerators because the denominators are the same. You'll notice that, sorry, that there's a 1 out here. So we're going to be going up by ones. 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi. And then we reduce. So this one looks fine, 3 pi over 4. 4's cancel out, pi. 5 pi over 4 looks legit. This is a 2 and this becomes a 3. These are some really weird fractions we're getting, right? And 7 pi over 4. You can imagine the kind of math that we would have to do theoretically if we wanted to go ahead and actually do this with math, okay? Great. And my apologies. I'm realizing as I'm doing this, you might need more paper, right? So you might want to do this on a separate sheet of paper and attach it, just so you can keep some sanity. I'm going to go ahead and make the graph. And the amplitude was 4. This is a positive cosine. So 1, 2, 3, 4. 1, 2, 3, 4 negative, right? This asymptote right here at positive 4 and 1 at negative 4. Cosine, so it would look like 1 right here, 1 right here, 1 down here, 1 over here, and then 1 as another max. And it would look like this. However, we have this k value. So what happens is everything drops down by 1, okay? In other words, this point at 4 would drop down to 3. This one at 0 would drop down to 1. Negative 1, I'm sorry. This one at 4 would drop down to negative 5. This one at this point right here, from 0 would down to go negative 1. And this one at 4 would go down to 3. And I'm dropping each of these by 1 because the k value is negative 1. Okay, so this is really what my graph would look like. I'm going to erase the gray one. Okay. And that is a graph of that is the official graph. So the asymptote technically, if you're interested in that, it's at 3 now and it's at negative 5 now. To summarize, what is the difference between sine and cosine graphically?